Welcome to this explainer. I am so thrilled to have you here today because we're jumping straight into a deep dive on something that's literally reshaping mobile technology. We are unpacking Google's totally vertically integrated AI stack. So we're talking about the heavily anticipated Pixel 11 Pro, Android 17, and the new LiteRT framework. If you've ever found yourself wondering how these tech giants are managing to cram massive, super intelligent models into a device that slips right into your pocket, well, you are in the perfect place. We're going to break down exactly how they're pulling this off, layer by layer.
So let's start by looking at the core of the problem, right? How do you actually fit an AI supercomputer in your pocket? Because this is the central conflict of modern mobile AI. On one hand, we want our phones to be incredibly smart. We want them to, draft emails, edit photos like a pro, act as these real-time conversational agents. But on the other hand, large language models are massive. They are incredibly power-hungry. A smartphone is fundamentally limited by its physical size, its battery capacity, and its thermal limit. I mean, you can't just slap a server-grade GPU into a phone without it literally melting in your hand or draining the battery in 5 minutes flat.
To see how they solve this, here's our roadmap for today. We'll look at the Pixel 11 Pro, Android 17 OS, the LiteRT framework, TurboQuant, and Proactive AI.
But before we get into the tech stack, we have to talk about the AI memory crisis. And the main culprit here is the key-value cache. You can basically think of the key-value cache as a high-speed digital cheat sheet. When an AI generates a response, it stores intermediate data in this cache so it doesn't have to recalculate absolutely everything from scratch just to guess the next word. It's a brilliant shortcut. It speeds up responses tremendously. But there is a catch. These high-dimensional memory vectors are absolutely enormous. As an AI model scales up, this digital cheat sheet grows so fast that it severely drains the device's memory. It's kind of like trying to force a fire hose of information through a regular garden hose.
To fix this, Google built the solution from the ground up. Layer 1 hardware, Pixel 11 Pro.
Let's walk through these leaked hardware specs because they are absolutely crucial to understanding this breakthrough. First up, the Tensor G5 chipset, which is reportedly built on TSMC's cutting-edge 2-nanometer process. Let me tell you, moving to a 2-nanometer architecture is huge. It drastically improves thermal management and power efficiency. You pair that with a massive 16 gigabytes of RAM, and you finally have the raw, brute force power and the thermal stability you need to run generative AI tasks locally without the phone overheating.
And this next point highlights a subtle but really vital hardware change. By reportedly ditching their older modems for the MediaTek M90, Google is finally resolving those historical complaints about 5G signal drops and excessive cellular battery drain. Now you might be wondering, why does a modem matter for AI? Well, because every single ounce of battery life you save from hunting for a network signal is an ounce of power preserved for running complex on-device AI. It is all about maximizing efficiency.
Okay, but raw hardware still needs software to orchestrate it, right? So let's look at Layer 2, Android 17 OS, acting as the NPU arbiter. Before we get completely under the hood, Android 17 is bringing some super exciting user-facing features to the surface. We're talking app bubbles that turn any app into a floating window for seamless multitasking. There's screen reactions, which is really cool. It uses dual cameras so you can record your screen and your face simultaneously, no green screen needed. And for foldable users, there's a dedicated 50-50 split gaming layout that optimizes the screens beautifully. But definitely take note of that last bullet point, app memory limits to prevent lag. That right there is our big hint at the deeper intelligence running the show.
Because this brings us to the real star of Android 17's AI capabilities, the NPU manager. NPU stands for Neural Processing Unit, which is the specific part of the chip dedicated just to AI. The NPU manager essentially acts as a strict OS-level traffic cop. So if you've got a multi-gigabyte AI model trying to run, the NPU manager dynamically gates it and adjusts its priority based on the phone's current thermal boundaries and active memory. It guarantees that these heavy AI tasks never starve your foreground apps, and they don't unexpectedly kill your battery. It keeps the whole system running perfectly in harmony.
All right, so hardware and OS are in place. Now we need the engine to execute the commands. Layer 3, LiteRT, the AI framework.
LiteRT is honestly a monumental shift for the industry. It's the cross-platform successor to TensorFlow Lite. While a lot of legacy systems were kind of just patched together over time to handle mobile AI, LiteRT was designed from day one specifically to unlock the massive power of modern neural processing units. It uses this new compiled model API, which means LiteRT automatically negotiates tasks. It instantly knows if a specific command should be routed to the NPU, the GPU, or the CPU for maximum efficiency. It completely eliminates that legacy lag we used to see all the time.
Just look at the difference between the old way and the new way. In legacy AI processing, moving data around, let's say from your camera sensor over to the AI model, required these costly CPU-mediated memory copies. The CPU basically had to act as a middleman, constantly copying data from one bucket to another. This totally drained the battery and caused latency. But LiteRT introduces zero-copy interoperability. This completely eliminates the CPU middleman, granting the AI model direct, instant access to the hardware memory.
To put that into perspective, removing that CPU middleman translates to a massive user benefit. It is exactly what makes these advanced real-time features possible. When you're processing night sight video on the fly, or if you're recording 8K video at 30 frames per second, the camera and the NPU are now just talking directly to each other without freezing up your phone.
Okay, but we still have the issue of fitting those massive models into memory, right? Let's move to turboquant compression magic.
I know this sounds like a lot of heavy jargon, but the concept is basically magic. Google is essentially rewriting the whole blueprint of AI memory to make it smaller and smarter. First up, you have polar quant. This takes standard, bulky Cartesian coordinates and shrinks them way down into compact radius and angle values. Then the second step sweeps in a layer called QJL, or quantized Johnson-Lindenstrass. Because compression naturally causes tiny errors, QJL fixes them. And it does it using just a single bit, so it completely preserves the AI's genius, but it takes up a fraction of the space.
So, what is the result of all that complex math? A massive 6 times reduction. TurboQuant achieves a 6x reduction in that key value cache memory usage we were talking about earlier. And the best part? It does this without sacrificing any of the downstream results. The AI is exactly as smart as it was before, but it only takes up 1/6 of the space.
And because the data is now so light and compact, the system's attention computations, which is basically how the AI prioritizes information, these now run up to 8 times faster. Google can push this extreme compression down to just 3 bits, and they don't even need to retrain the models to do it. The impact here is just huge. You're getting lightning-fast, highly responsive AI that doesn't hoard your phone's memory or completely drain your battery.
Bringing all these pieces together leads us to our final takeaway: the proactive AI future.
By engineering this perfectly harmonious, vertically integrated stack, the 2nm Tensor G5 hardware, the NPU manager in Android 17, and the LiteRT framework paired with that incredible turbo-quant compression, Google has fundamentally solved the mobile AI bottleneck. They are transforming the smartphone from a passive tool that just sits there waiting for your input into a proactive, multimodal agent. It actively anticipates your needs, it processes really complex data locally, and it keeps all your private information strictly on your device.
We are officially crossing a threshold where the hardware and software are no longer holding the intelligence back. As our phones rapidly evolve into these highly capable, autonomous agents, I want to leave you with this question to ponder. When you have this much incredible power operating seamlessly in your pocket, what will you have your Pixel do first? Thank you so much for joining me for this explainer, and keep learning.